Assalamualaikum, greetings to Dr. Nordiana. We are from Group 3, Section 2, and our title for our project Electric Field Distribution on 275 kilovolt silicone rubber polymeric alternate shade insulator. First of all, I would love to introduce myself and my fellow group members. My name is Nur Izzati binti Omar, number matric CE19011. Next is Nuruzana binti Abdullah, Nurul Ismahani, Arifah Nur Kalishah, and lastly Siti Nurlina. Electricity is an important part of modern life, whether you live in a rural place or a city. For economic consideration, electricity must be transported at high voltage. Creating wire insulation that can withstand such high pressure is a significant challenge. Therefore, overhead lines are typically utilized for long-distance power transmission. We know that high-voltage insulators are necessary for transmission line to prevent electrical discharge and maintain system integrity, because without them, there could be power outage, broken equipment, and risk to public and worker safety. So, it is important to choose the right material for the insulation. The most common raw material for insulation are porcelain and glass. Due to their stress resistance, these materials are the most common for insulator construction. Furthermore, for the problem statement, stress could harm the overhead line, which average 0.5 to 10 insulation failure per 100 miles per year. Transmission line high voltage insulator cannot fulfill the power industry expanding need, producing frequent power outage, public safety issue, and significant utility financial losses. Existing solution cannot resist extreme weather, limit corona discharge, or prevent flashover, which is destroy equipment and endanger public safety. If these out-of-gate insulator are used, production, downtime, and public safety will suffer. And for our project objective, these are the objectives that we need to achieve. Firstly, we need to design HVE insulator using suitable technique. Secondly, to create a 2D or 3D sketch of the suggested design and to simulate the HV and EM field distribution for the purpose prototype. Lastly, to determine the test setup for proper HV testing that consider the right tools, safety precaution, and workable processes. This analysis focus on how prototype performs under environmental stress. And lastly, for the scope of work in this project, a HV insulator can withstand up to 275 kilovolt. The type of HV insulator is long rod. The fitting used for the HV insulator are bolts and nuts. HV insulator is made up from polymeric material alternate shade. And lastly, the maximum length for the HV insulator is 2,750 millimeter. That's all from me. We move to the other group's member. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Arifah Nur Kalishah binti Khalid. My matric number is AE190057. So I will continue with my part, which is the design planning. So for the design planning, our project decided to use 275 kV polymeric material. So this is our flow chart. After decide the insulator that will be used, we need to determine the amount of load that will pass through it. So our project, the specification is 275 kV. So next, we will study the design of insulator. So the insulator parameter are determined using the study's outcome. After that, the insulator design overview is created using reliable drawing tools. Lastly, considering the insulation parameters, which is its performance and other factors. So as we know, our project using polymer insulators. Okay, polymer insulator can be categorized into three types, which is thermoplastic, thermoset, and elastomers. So polymer insulators typically consist of three parts, which is insulator section, insulation coil unit, flange, which is the end terminal, and screen fittings for insulator fittings. So next, I will continue with the mechanical and electrical characteristic. So for mechanical characteristic, it should have high mechanical strength. The insulator material should be free from impurities and crack. The last one is high corrosive strength, shear strength, bending strength, and impact strength. So for the electrical characteristic, high electrical resistance of insulator material, high relative permittivity of insulator, and the last one should not be affected by the temperature. Our project is using long rod type of insulator. So I will tell you the advantages and the disadvantages. So for the pros, each unit can operate on a voltage around 11 kV. It is less pricey than other insulator. It is immune to the thermal puncture. So what is the disadvantages? So the first one, it is difficult to carry around since it cannot be separated. It lacks flexibility, and it is hard to replace with a new one if one disk happen to be damaged.
Assalamualaikum warahmatullahi wabarakatuh. To Dr. Diana, my name is Siti Nurlina binti Azmi. My matrix number is 819030. Right now, I am going to discuss based on the result that we obtained from the simulation. So for the first one is the result on field intensity on dry conditions. So here is the result based on the simulation, where the intensity on the dry condition without grading is spread evenly and freely. So this is without the grading, and after we put the grading with 1000 permittivity of the grading, the visual simulation is like this, and the intensity on the dry condition with the grading seems attracted to the grading because of the right side is more concentrated to the grading rather than the left side. Okay, next, the result on field intensity of wet conditions. The intensity on the wet condition are more concentrated at the bottom, and it is more lesser than the previous one, which is the dry condition. And the intensity on the wet condition with grading is, it happens to be more concentrated to the grading, and it seems like it attracted to the field of the grading. And the field, same as the previous one, the field at the right side is more higher than the left side. Next one is the result of field intensity on contamination condition, where the condition, the intensity of the contamination condition is more concentrated at the bottom. The result is quite same as the previous one. And the intensity on contamination condition with grading, we obtain the same as the wet condition, and the field seem attracted to the grading ring, and the right side is more concentrated rather than the left side. So this is the result of comparison of voltage graph with and without grading on various conditions, which includes the dry, wet, and contamination conditions. So for the first one is the dry condition. We can see here that the graph without grading, the voltage was 1 exponent of 5 volt, while with grading is 1.5 exponent 5 volt. The with grading one is the higher than the without grading. Next is the wet conditions. The without grading, the volt is 1.5 exponent 5 volt, while after we put the grading, the output of the wet condition was 9 exponent 4 volt, where from this condition that shows that the output voltage with grading is higher than without the grading, but the voltage is much lower than the dry condition. Okay. So for the last one is contamination. As you can see here that the output voltage without grading is 1.5 exponent 5 volt, while after we put the grading is in the range of 9 to 1 exponent 9 exponent 4 and 1 exponent 5 volt. So here is the output voltage is with grading is higher without grading, but the voltage is lower than the dry and wet conditions. So why? Because the wet and contamination condition has its permittivity that lead to the voltage to be decreased rather than the dry one. Okay, next is the comparison of field intensity graph with and without grading with condition dry, wet, and contamination condition. For the first one without grading, we can see that the range of the field intensity was 1.5 exponent 5 volt 5 volt per meter to 2 exponent 6 volt per meter. So in this graph shows that the output field with grading is higher than without grading. And for the wet condition, the output field with grading is higher without grading, but the peak field is higher than the dry condition. So here we can see that the peak is about 8 exponent 6 to 9 exponent 6 volt per meter, while the dry condition is about 3 to 4 exponent 6 volt per meter. And the last one is the contamination condition. The output voltage with grading is much higher than without grading, but the peak is same as the wet condition. So the peak here, as we can see here, that the peak was the same as the wet condition, but as we can compare from a wet and contamination condition, the wet contamination condition is much steeper to increase the intensity rather than the wet condition. Thank you.
Assalamualaikum and good afternoon. My name is Nurul Ismahani binti Muhammad Jaswadi and my matrix number is AE190028. Now I'm going to present for the simulation part. So as my other member mentioned before, so our group project is about the Polymeric Insulator 275 kilovolt alternate shade. So for simulation, I will show only for the dry condition for with grading ring and without grading ring. So as mentioned before, for our group is alternate shade type. So here as you can see, we have for the insulator we have the big one and then the small one and then a big one and then the small one. So this is alternate shade mean. So for the insulator, we use the long rod type. So here, as you can see, for the material we choose for our insulator is for the core is steel and for the weather sheet for the insulator is silicone. So now, and the material condition around the insulator is we choose as air. So this for the dry condition without a grading ring. So now I'm going to mesh it and analyze. Okay, this is the result we got for the dry condition after we simulate it. So as you can see here, the field intensity more focused at the system voltage, which is at here we set 275 kilovolt, and you can see the field intensity more focused on here. And now we're going to see for the graph. So yeah, get it here. Oh, and the straight line here is for us to take the reading, the graph reading for our project. So this is for voltage. And next is magnetic field intensity. So this is graph for the magnetic field intensity. So now we back here, and then we going to create to design with the grading ring. So okay, so 180. Okay, now oh, wait, we need to. So material we choose for the grading ring is metal. So here, and then this is open boundary. So open boundary. Okay, now mesh it. Okay, now analyze. Okay, this is the result, the dry condition with the grading ring. As you can see, if you can zoom it. Wait, I will try to zoom it. Okay, the field intensity more attracted at the grading ring here. And also the in field intensity also more focused at the system voltage. Okay, now we're going to see for the graph. Okay, this is for the voltage, and this is for the magnitude field intensity. So that's all from me. Next, I will pass for my others member to tell you more about the condition for our insulator. So that's all from me. Thank you.
In this project, the high voltage test method chosen is switching and lightning impulse test, which is categorized as destructive test. This type of test is used to ensure the apparatus has an ability to withstand the normal and abnormal system voltage, which meet the requirement by standard. As we can see from the diagram, an impulse set which used to produce a lightning impulse and switching impulse waveform is used to supply the positive or negative impulse voltage to the test circuit, and its output voltage is measured by using a capacitor divider. After setting up the test equipment, the flashover or withstanding ability is monitored. Normally, data is collected through the current voltage measurement, the condition of pre- and post-impulse wave shape, visual condition, streamer's propagation, visual flashover, and occurrence of damage. As this test includes over-voltage equipment and the lab surrounding are having various of hazards, hence we need to practice a good safety precaution. For example, the attire used while conducting the test is personal protective equipment, PPE, glove, fire-resisting clothes, and insulated boots. Other than that, we must know the location of emergency stop button before conducting experiment for safety purpose. As conclusion, switching and lightning impulse tests are suitable in this project because they are designed to simulate the high voltage thrust that the insulator will experience in service. Switching impulse tests are used to simulate the transient overvoltage that occur during switching operation in power system. These tests are conducted by applying a high voltage pulse with a fast rise time to the insulator and measuring the response. Both tests are important for ensuring the reliability and safety of the insulator in service. By conducting these tests, any weakness or defects in the insulator can be identified and addressed before it put into service. Thank you.